All right, here we go, my friends. Our first video this semester is going to just catch you up on what correlations are. If we don't have time to really delve in class, this is somewhere you can learn a little bit more about correlations. Okay, something very important that comes up. Not only in this course, but in all kinds of other sciences and psychology courses you might take. Okay. So first of all, let's get the definition straight. Correlations are basically two traits or two attributes that are related to each other. They correlate. Okay, so you can use the word itself to remind you of what it means. It means that two things are related to one another. It really doesn't mean anything more than that. They're just related. Okay, and for the purposes of science and psychology, we want to measure how closely things are related and how we can predict what happens when we observe change in one, what happens to the other. Okay? Prediction is something very important for us scientists. So if we know the two things are related, then we might be able to predict what's going to happen to one if we know the other. So I want you to remember that correlations are great predictors. If the correlation is strong, it's going to have a great predictive power. Okay, great predictive power. What the correlation doesn't have, though, it doesn't have a causal power. We just know that the two traits or the two events are related to one another, but we cannot say which one caused the other or whether there was something else that caused both of them. So we have to be very careful because our human nature wants us to say, oh, this caused this. If it's a correlational statement or correlational relationship, we can only predict. We cannot determine causality. Okay, we'll do a couple of examples so you can get a hang of this. Number one, positive correlations. Remember, we're going to talk about positive, negative, and hey, no correlation. Okay, positive, negative, or no correlation. Before we begin, when you think about the word positive, you always want to attach an emotional meaning to it. Positive is good, negative is bad. Positive is kind, negative is mean. For the purposes of this correlational business, though, we have to detach ourselves from the emotional meaning of the word positive and negative that we are used to understanding. Okay, so positive correlation simply means that the two events that we're looking at, the two traits that we're looking at, are changing in the same direction. Okay, positive means the same direction. So for example, our two variables increase. They both increase, or they both decrease. As long as the direction is the same, the correlation is going to be positive. Okay, so positive doesn't mean yes, there is correlation. Positive means that the variables that we're interested in are changing in the same direction. So for example, look on the slide, towards the bottom of the slide. As time spent in the sun increases, my chances of getting sunburn also increase. Guess what? Both things are going in the same direction. They're going up. So my correlation is positive. Now, check the other example out though. If I stop drinking soda, so if my soda intake goes down, hey, I might lose some weight. So my weight is going to go down as well. Here, the variables are decreasing. They're both decreasing. If they're both decreasing, my correlation is still positive. The trap here is that when we see decreasing, we think decreasing negative, so it must be a negative correlation, but it's a trap. You have to look at the direction. If both things are going in the same direction, whether it's increasing or decreasing, then we have a positive correlation. Okay? If you look on the graph towards the top of the slide, you're going to see what a positive correlation looks like if it's plotted on a scatter plot. It basically looks like the dots of the scatter plot are coming out from the zero kind of cross section of the axes, and they're shooting out from there. So the incline is going outward from the center of the axes. That's what it looks like. You don't even have to know what the variables are. You don't need to have to know anything more besides looking at the scatter plot to be able to say, hey, this is a positive correlation. The strength of the correlation can also be determined by just looking at this graph, because the closer these little dots are to each other and to a perfect line, the closer this correlation is to its maximum value, which is +1. And the most perfect the two variables are related. If you look on the second one, you're going to see dots scattered all over the place. There is no relationship here. So the closer together the dots are, the stronger the relationship between our two variables is. And depending on the incline or the shape of the line that we see, we can say, hey, this is a positive correlation, this is a negative correlation. Okay? So the values of these correlations go from 0 to +1 in the case of positive correlation. And then they go from 0 to -1 in terms of negative correlation, which we're going to take a look at next. All right? Now, very similarly, we are going to detach ourselves from the emotional meaning of the word negative. We can have a perfect negative correlation that we want it, that it's amazing, that it's good for our science. The word negative simply means that the variables that we were interested in, the variables that we have found that are related, are going to be changing in opposite directions. One is going up, the other one is going down. One is increasing, the other one is decreasing. The fact that they're going in different directions or in opposite directions means, hey, we have negative correlation. Negative correlation doesn't mean, wow, you got a bad correlation, mean correlation. No, it just means that they're going in different direction. So look at the examples. The more absences from school I have, so absences are going down, guess what's going to happen to my grades? My grades are going to go down. So these two variables are related. Absences from school and grades are related. And how are they related? The more absences, the lower the grades. Directions are opposite. Therefore, they have a negative correlation type relationship. Okay? The other example I have there. The more I run, or the more aerobic exercise I do, the lower the risk of heart disease. One is going up, my level of exercise, my amount of exercise, my days of exercise are going up, and guess what? My risk of heart disease is going down. One is going up, the other one is going down. Guess what? I have a negative correlation. As easy as that, okay? So now if you look at the graph up there of what a negative correlation looks like on a scatter plot, look, it kind of closes a triangle up there. It's an absolutely different shape. So you spot that scatter plot, you don't even need to know the variables. You can say, hey, these things are negatively related. One is going to be increasing while the other one is decreasing. That's all you will be able to say. And again, as far as the coefficient of this correlation, the maximum value of this negative correlation will be -1. If it looks like a perfect straight line, just it is like on the graph, its value will be -1. If there's more variability, if the two variables aren't as closely related, then we're going to see more like a cloudier shape of these dots being spread around until they look like the graph in the middle, where clearly they're all over the place and there's no relationship. Okay, no relationship. Just like, for example, the more absences from school, the lower risk of heart disease. Those two, maybe they don't have anything to do with each other, right? My absence from school don't necessarily predict my heart condition. So if I plot my absences and my heart condition, my graph is going to look like something like the middle. No relationship, cannot be predicted. Okay, so this really is everything about these correlations for now. Takeaway message on correlation, people. Takeaway message is this. Correlations are amazing predictors. If you have a good correlation, that you have amazing predictive power. If you know my absences from school, you might be able to predict how my grades are going to be. Okay? If you know how many hours I spend on the beach, you might be able to predict my likelihood of getting sunburn. It has a great predictive power. What it doesn't have is the ability to show us what caused what. If I have a lot of absences from school and my grades are low, did my absences cause me to have lower grades? Or my lower grades sort of bummed me out, made me feel bad, and I decided I don't even want to go to school anymore. So which one caused the other? It's a little bit like the chicken and the egg. Okay? If it's a correlation type situation, if I see a chicken, I know there's going to be an egg. If I see an egg, I know there's going to be a chicken. But which came first, I don't know. I cannot determine whether the chicken caused the egg or the egg caused the chicken. Okay? So remember that correlation does not prove causation. This is what this means. Correlation does not prove causation.